Hello all, welcome to Unacademy. Today we will see our second lecture on indeterminate forms. In this form we will see a 0 into infinity form. Okay. In this form we will see our 0 into infinity form, and here limit as extends to 0. Before going to start this, let me introduce myself. Myself Dhanashree. I completed my MSc in Mathematics from Mumbai University, and I also mentored more than 10,000 plus students and having 13 plus years of teaching experience. Okay, now we will start our actual topic. Before going to start our actual topic, let me tell you how to install the Unacademy's learning app. First, go to mobile's Play Store app and then search Unacademy's learning app. After that, you will install the Unacademy's learning app, and आफ्टर दैट मैनेज योर गोल. यहाँ पे हम लोग अब जैसे कि हम लोग यहाँ पे गेट एंड ईएसई के लिए पढ़ रहे हैं, सो यू कैन मैनेज योर गोल ओवर हियर and then get an subscription of your get an ESE either for plus subscription, free courses, special classes, anything you can choose over here, and press the button get subscription. So you will get the subscription of that, and here again you have to take the subscription plan for either for 12 months or 24 months, so that you will get it here 12 the plan will be for the 12 months or 24 months. So you will get here if you are going to prepare for the GATE 2022, then I will suggest you can take a plan of 24 months, so that year it will be more beneficial for you. And to get the 10% discount on it, you can use my promo code, that is DSP, so that you will get a 10% discount on your subscription fees, and you can pay your fees by using any one of this method. And the most important event will be going to here from the 28th December from 11:15 a.m. Okay, so you can enroll your batch here for the civil special batch जो हमारी start हो रही है batch A for English and Hindi starts from 28th December from 11:15 a.m. Okay, next is the next batch is for the GATE 2022 के लिए है, जो कि special batch है for mechanical batch A. It is also in English and Hindi. So it is start from 28 December from 6 p.m. यहाँ पे आप लोग देख रहे हैं बहुत सारे चेहरे जो है जाने पहचाने आपको लग रहे हैं. So you will get the coaching from the top educators from Unacademy. So that please take it टेक इट द मतलब यहाँ पे आप लोग उसका फायदा कीजिए. फ्रॉम 28 दिसंबर से 6 p.m. स्पेशल बैच फॉर मैकेनिकल. सो आई विल टेल यू योर कंप्लीट कोर्स विल बी covered from 28 December from 6 p.m. So be there, be watch. Now to unlock the free plan of Unacademy with you can use my promo code with DSP, so that you will get the 10% discount for any batch, for special classes, for live test series, for quiz, or for any Unacademy combat. Okay, you can use my promo code. Now the first, yeah, first we have seen the indeterminate form. It is 0.0 indeterminate form. In the last lecture we already seen 0.0 indeterminate form and infinity upon infinity indeterminate form. In this lecture we will going to see the indeterminate form of 0 into infinity. So what we will do, so suppose first of all put the limits limits from f of x from x tends to 0 x tends to a is equal to 0, and limit of g of x as x tends to a is equal to infinity. Then the limit of x, f of x into g of x tends to a, is in the form 0 into infinity, from which can be evaluated as follows. Let L is equal to limit as x tends to a into f of x into g of x, where 0 into infinity form, adjusting either f of x or g of x in the denominator, so that the limit reduces to the form either 0 upon 0 or infinity upon infinity. Now let limit as x tends to a, f of x upon 1 upon g of x, so which is converted into 0 upon 0 form. So this can be evaluated by using L'Hospital's rule. Note that in this type of limits, one of the term involve logarithmic function, then it is kept in the numerator and adjust the other term in the denominator. So what will be this? I will tell you in the solving example, while solving the example. Okay, we will see examples one by one. Whenever the indeterminate form, अगर आपका यहाँ पे indeterminate form 0 into infinity आ रहा है, तो आपको either it is converted into 0 upon 0 form or convert it into infinity upon infinity form. Now yesterday we have seen how to evaluate the 0 upon 0 form and infinity upon infinity form. Okay, in this lecture we will see how to evaluate the 0 into infinity form, right? So 0 into infinity form, for that we will adjust your f of x and g of x like this. Either it is converted into f of x upon 1 upon g of x or g of x upon 1 upon f of x, so that we can evaluate easily this indeterminate form. Now evaluate limit as x tends to pi by 2, 1 minus sin x into tan x. Right, evaluate this. For this, put x tends to pi by 2. So if x tends to pi by 2, here sin pi by 2 is 1. So if you observe 1 minus 1 and tan pi by 2 is infinity. So this will be your form 0 into infinity form. So what we will do, we will adjust one of them terms so that it will converted into either infinity upon infinity or 0 upon 0 form, right? So let L is equal to what, how we can write this? L limit as x tends to pi by 2. We can write this tan x 1 minus sin x upon here tan x, I can write here 1 upon tan x. Okay, instead of writing into tan x, I am writing 1 upon tan x. Now if you observe here, see here 1 upon tan x tends to pi by 2. So sin pi by 2 is 1. So 1 minus 1, it is 0, right? Upon 1 upon tan pi by 2 is infinity. So 1 upon infinity is again 0. So it is here is 0. So it is converted into 0 upon 0 form. Now we can evaluate this 0 upon 0 form by using L'Hospital rule. Okay, so we will write in here 1 upon tan x. So 1 upon tan x is nothing but, I am writing this one limit as x tends to pi by 2. 1 minus sin x upon 1 upon tan x is nothing but cot x, right? In 1 upon cot x. Now put limit as x tends to pi by 2. So using L'Hospital rule, by using L'Hospital rule, we will have limit as x tends to pi by 2. Limit as x tends to pi by 2. Now derivative, L'Hospital rule क्या है? Derivative of numerator upon derivative of denominator. So you will get here derivative of 1 is 0 and derivative of sin x is cos x upon derivative of cot x is minus cos x square x, right? Now here is, you will get minus cos x upon minus cos x square x, right? So here put cos pi by 2. Cos pi by 2 is 0. Right? Minus minus get cancel out this. And cos x square pi by 2. So cos x square pi by 2, it means 1 upon sin square pi by 2, right? So here cos x square pi by 2 is 1. So 0 upon 1. So you will get the limit of this function is 0. So this is how we can evaluate this. I hope you are clearly understood how to evaluate the 0 into infinity form. Okay. Now next one we will see this example. To evaluate limit as x tends to 1, 1 minus x into tan pi by x, pi by 2 into x. So put here x tends to 1. So here x tends to 1, you will get 1 minus 1 is 0. Again tan pi by 2 is infinity. Again it is 0 into infinity form. So what we will do, we will adjust this tan pi by x, pi by 2 into x here. Okay, so we will adjust this tan pi by 2. So L is equal to limit as x tends to 1, 1 minus x upon, we can write here 1 upon tan pi by 2x is nothing but cot pi by 2x, right? So is it nothing but 0 upon 0 form? as it is converted into 0 upon 0 form. So using an hospital rule, we get L is equal to, here limit as x tends to 1, right? So 1 minus x upon cot pi by 2x. So 1 minus x you will get here minus 1 upon cot pi by 2x. So you will get minus cosec square pi by 2x into pi by 2, right? Now put limit as x tends to 1. So cot cosec square. So here is cosec square pi by 2x into pi by 2. Now put limit as x tends to 1. So which is equal to 1 upon, now minus minus becomes plus. Now pi by 2. So here you will get minus 1 upon minus 1 upon minus 1 into pi by 2. So this, is it nothing but 2 by pi? So the value of limit as x tends to 1, 1 minus x into tan pi by 2x is 2 by pi. Now let's check. Evaluate limit as y tends to infinity into y square into 1 minus e raised to minus 2gx upon y square. This is totally different example. Now limit as y tends to infinity, right? So e raised to minus infinity. As we know that here e raised to minus infinity is 0. So here e raised to minus infinity is 0. So here is infinity. So this is infinity into 0 form. Are you getting it? Infinity into 0 form. So as it is infinity into 0 form, we can convert it into, so L is equal to, here put y is equal to 1 by t. Now see how we can write it. Y is equal to 1 by t, so which implies t is equal to 1 by y. So as y tends to infinity, what it imply? T tends to 0. Right? So therefore limit as L is equal to limit as t tends to 0, 1 upon t square, instead of y here 1 by t, 1 upon t square, 1 minus, here is minus 2gx into t, 1 upon y square, it means here is t square, minus 2gx into t square. So L is equal to limit as y tends t tends to 0. So here 1 upon t square into 1 minus, so you will get, as t tends to 0, is it nothing but 0 upon 0 form, right? E raised to 0 is 1, so 1 minus 1, so this will become 0 upon 0 form, right? Now you will get L is equal to limit as t tends to 0. Here is 1 minus e raised to minus 2gt square, right? Plus 2gx into t square upon t square. Now using L'Hospital rule, we get, using L'Hospital rule, we get here limit as t tends to 0, L is equal to limit as t tends to 0. Here limit as t tends to 0, so you will get, your derivative of 1 is 0, so minus e raised to minus 2gx into t square. So derivative of minus 2gx, so here is minus 2x is constant, and derivative of t square is 2t upon 2t, right? So here upon 2t, so upon 2t, so this will get cancelled out, minus minus becomes plus. Now put t tends to 0, so it is nothing but minus minus plus. So here 2gx into e raised to 0 is 1. So you will get value of this limiting function, the value of this function is 2gx. Okay. Now next. Now see the example number 4. Evaluate limit as x tends to 0, x into log sin x. So we can evaluate this limit as x tends to 0 into x log sin x. So x log sin x, limit as x tends to 0, right? So limit as x tends to 0, x log sin x. So put limit x tends to 0. So 0 into log of sin 0, 0. So log 0 is infinity. So you will get here 0 into infinity form. Here is 0 into infinity form. Now limit as x tends to 0, x log sin x is equal to, you will get limit as x tends to 0, x into log sin x, log sin x. So we can adjust our 1 upon here x is log sin x upon 1 upon x, right? So you will get here infinity upon infinity form, right? Sin 0, 0, log 0, infinity upon 1 upon 0 is again infinity. Okay, so using L'Hospital rule, we get here limit as x tends to 0, right? Log sin x. So log of sin x 1 upon sin x into cos x, 1 upon sin x into cos x upon minus 1 upon x square, right? So minus 1 upon x square, which is equal to minus of limit as x tends to 0. Here we will get, we can adjust this 1 upon x square is nothing but x square upon sin x, right? This x square becomes in the numerator, right? So x square upon sin x into cos x, right? So limit as x tends to 0, L is equal to minus into limit as x tends to 0, x square upon sin x, so x upon sin x into x cos x, right? So here limit as x tends to 0, x upon sin x is equal to 1, right? So you will get here limit as x tends to 0, so that is equal to 1. So as x tends to 0, here x is equal to 0, so you will get limiting value L is equal to 0. I hope you are getting it clearly. Now next example we'll see. Here indeterminate form of infinity minus infinity. Now if we see here infinity minus infinity form, now let limit as x tends to a, f of x minus g of x be in the infinity upon infinity minus infinity form, then in this case we take a cross multiplication. Okay, if we come across in infinity minus infinity form, then in that case we will take a cross multiplication or LCM and express the limit in either 0 upon 0 or infinity upon infinity form. In this case we take cross multiplication and express the limit in either 0 upon 0 or infinity upon infinity form, which can be evaluated by using L'Hospital rules. Okay, now yeah, evaluate one limit as x tends to 2. So 1 upon 2 minus 2 minus 1 upon log of 2 minus 1. So 1 upon 2 minus 2, that is 0. 1 upon 0 minus 1 upon 1 minus 1, log 0 infinite. Log here 0 is infinity. So you will get here log 1. Here log 1 is 0. So 1 upon 0 and 1 upon 0. So that is infinity minus infinity form. Now, so what we will take? We will do the cross multiplication. Okay. So here we will get cross multiplication log of limit as x tends to 2 log x minus 1 minus x minus 2 upon x minus 2 into log of x minus 1. Okay, so you will get by therefore by L'Hospital rule, Therefore, by L'Hospital rule, we get limit as extends to 2, limit as extends to 2, 1 upon log of x minus 1 derivative 1 upon x minus 1 minus 1 upon here u into v x minus 2 into 1 upon x minus 1 plus log of x minus 1, right? So put limit as x tends to 2. So x tends to 2, 1 upon 1, 1 minus 1, 0. Here is 0, 0 upon 0 form. Okay. So again we will take L'Hospital rule. So you will get limit as, again by using L'Hospital rule. Again by using L'Hospital rule, we get here L is equal to minus 1 upon x minus 1 bracket square minus 0 upon here x minus 1 okay, x minus 1 into 1 minus x minus 2 into 1 upon x minus 1 bracket square 2 upon v rule, okay, plus 1 upon x minus 1. So limit as x tends to 1, x tends to 2, sorry, as x tends to 2. Now put here x limit as x tends to 2. So here limit as x tends to 2. So ultimately here x minus 1 minus x minus 1. So you will get here only 1 upon minus minus plus 2 plus x minus 6 can cancel out and 1 minus 2. So L is equal to limit as x tends to 2. You will get here minus 1 upon is minus 1 upon x minus 1 minus x plus 1 cancel out plus 2 minus 1 1 1 upon x minus limit as x tends to 2. So you will get here 2 minus 1 bracket square 1 plus 1 upon 2 minus 1 1. So minus 1 by 2. That is minus 1 by 2 limit as x tends to 2. This is your final. So see, evaluate limit as x tends to 1. X upon x minus 1 minus 1 upon log x. Exactly similar form. So as x tends to 1, so you will get here 1 upon 1 minus 1. That is 0. 1 upon 0 it means infinity and 1 upon log 1 is 0. So 1 upon infinity. 1 upon 0 it means infinity. So you will get infinity minus infinity form. So what we will do? We will do the cross multiplication. So limit as x tends to 1 x log x minus x minus 1 upon x minus 1 into log x. So which is equal to limit as x tends to 1 x log x minus x minus minus plus 1 upon x minus 1 into log x. Now put limit as x tends to 1. So L is equal to limit as x tends to 1. Here x tends to 1. So log 1 is 0. So this is 0. Minus 1 plus 1 again 0. So you will get here 0 upon 0 form. Right? So this is our 0 upon 0 form. No. Used by L'Hospital rule. By L'Hospital rule, we get by L'Hospital rule we get here L is equal to limit as x tends to 1 x into log x. So first derivative of second plus second into derivative of first minus 1 upon first into derivative of second, second into derivative of first. ये plus 1 minus 1 cancel out हो जाएगा. So log x upon, here is 1 upon x. So 1 minus 1, 0, and log 1, 0. Log 1, 0. Again here is 0 upon 0 form. Right? Here is only log x and here is 1 upon x. So ultimately x minus 1 upon x plus log x. So plus x log x upon x, it means x log x upon this. Okay. So you will get this. So limit as x tends to 0. Otherwise we can use here the x into log x. Only log x upon x into 1 by x is 1 and minus 1 by x plus log x. Right? So it's a very simple to find out the L'Hospital rule. So using L'Hospital rule, here we have L is equal to log x, limit as x tends to 1, as x tends to 1, log x, it means 1 upon x upon minus plus 1 upon x square. हो जाएगा plus 1 upon x square plus 1 upon x. Right? So limit as x tends to 1. So 1 upon 1, it means 1 upon 1 by 1 plus 1 by 1. So 1 plus 1, 2. So L is equal to 1 by 2. Yep. Now, let's see the next example. Limit as x tends to 0, a upon x minus cot x upon a. Right? Cot x upon a, put limit as x tends to 0. So a upon 0 is infinity and cot 0 is again infinity. Okay? So you will get here 0 upon 0 infinity upon infinity form. Now, so as infinity upon infinity form, so हम लोग ये कैसे करेंगे? 1 upon tan x by a, cot x by a, it means you will get here limit as x tends to 0, a upon x minus 1 upon tan x by a. Right? So you will get here 1 upon limit L is equal to limit as x tends to 0, a into tan x by a minus x upon x into tan x by a. Right? So apply limit as x tends to 0, a into tan 0 is 0 here, 0 minus 0, so you will get 0 upon 0 form. Once you get the 0 upon 0 form, L is equal to limit as x tends to 0. So here you will get a into tan x by a, that is a into sec square x by a. A into sec square x by a into 1 by a. Right? Minus 1 upon first into derivative of second square x by a into 1 by a plus second into derivative of first tan x by a. Right? Now put limit as x tends to 0. So again limit as x tends to 0, we will get this a and this a get cancelled out. So sec square x by a minus 1. Right? Here you will get limit as x tends to 0. There is sec square x by a minus 1 upon this 1 by a. Now this is 0. So again here you will getting 0 upon 0 form. 0 upon 0 form. So x square x by a, here is 1 by a, x by a into x square x by a, right? Or 1 by a into x square x by a plus tan x by a, right? Plus here tan x by a. So you will get limit as x tends to 0, limit as x tends to 0, you will be getting x square x by a minus 1. So here's x square x by a minus 1. So again using L'Hospital rule, so we will get here 2 into x square x by a to tan x by a to sec x tan x, right, into 1 by a, and derivative of minus 1. Okay. Here 1 by a as it is into first into derivative of second. So x into 2 into sec square x by a into tan x by a upon 1 by a plus x square x by a into 1 by a, right? Okay. Now here L is equal to, so put limit as x tends to 0, as limit x tends to 0, here sec square 0, 0, tan 0 is 0, so 0 upon 0 form. Again here is 0, sec square 0, so you will get here total value is 0. Now 1 by a into x is 0, so this is 0 plus here sec square 0, so here is 1, square 0 is 1, so 1 by a, so 1 by a, and here is plus 1 by a. Okay, limit as x tends to 0, so 0 upon 1 by a to 0 plus 1, right? 1 by a into 0 plus 1, it means here, and sec square x by a, where 0 is 1, again 1 by a, right? So plus 1 into 1 by a, this will becomes 0 upon anything is here. I hope you are getting it clearly. So it is 0 upon form is here. So next is C. Evaluate limit as x tends to 0, 1 upon x minus 1 upon e raised to x minus 1, right? So x tends to 0, 1 upon 0 infinity, 1 upon e raised to 0 1, 1 upon 1 minus 1 0. So 1 upon 0 again here is infinity minus infinity form, right? Here is infinity minus infinity form. Now, so use let L is equal to limit as x tends to 0. Here is using L'Hospital rule 1 by x minus here e raised to x. So cross multiplication, e raised to x minus 1 minus x upon x into e raised to x minus 1. Right? So L is equal to limit as x tends to 0. Here is u upon v rule. So we will get e raised to x minus 1. So not u upon v. Here we can use L'Hospital rule. So L'Hospital rule is x square e raised to x minus 1 upon first into derivative of second plus second into derivative of first. Okay, right here same, put e x tends to 0. As x tends to 0 you will get e raised to 0 is 1, 1 minus 1 upon x tends to 0, so this will become 0. So here is 0 upon 0 form, right? So L is equal to, now take the derivative again, x into e raised to x minus x, right? There is only plus minus 1 now. Derivative of e raised to x minus 1 is e raised to x. So x into e raised to x plus e raised to x minus 1. Now x tends to 0. So again using L'Hospital rule, again using L'Hospital rule, so take the derivative, limit as x tends to 0. Here derivative of numerator, that is e raised to x, upon derivative of this numerator denominator, first into derivative of second, first second into derivative of first, plus e raised to x. Okay, now put x tends to 0. So e raised to 0 is 1 upon, here is 0, so this will become 0, e raised to 0 1, e raised to 0 1. So 1 plus 1, so here is 1 by 2. This is the final answer for the given infinity minus infinity form. It is a special form. Now the next form is 0 raised to 0 or, or infinity raised to 0 excuse me, or 1 raised to infinity indeterminate form. So in that case, what we will do, limit as x tends to a, f of x raised to g of x in the form of 0 raised to infinity or infinity raised to 0 or 1 raised to infinity. Then to find the limit, we proceed as follows. देखो यहाँ पे क्या करना है, log की concept लेनी है हमें. L is equal to limit as x tends to a, f of x raised to g of x. अगर आपका लिमिटिंग फंक्शन है यहाँ पे limit as x tends to a, f of x raised to g of x है, then taking log on both sides. So if you take log on both sides, so you will get L log L is equal to, now g of x becomes here, so limit as x tends to a, g of x into log of f of x, right? So the above limit will be in the form of either 0 into infinity, which can be obtained by using the above process just now we have studied, and let the limit say b. So log L is equal to b, then L is equal to e raised to b. Okay. Now let's see. Now limit as x tends to infinity, 1 upon x raised to 1 by x. So what will happen? Limit as x tends to infinity, 1 upon x raised to 1 by x. So put limit as x tends to infinity. So 1 upon infinity, it means 0. 0 raised to 1 upon infinity. So it is 0 raised to 0 form. Right? Here is 0 raised to 0 form. If you put here, if you put x tends to infinity, 1 upon infinity is 0 raised to 1 upon infinity, so 0 raised to 0 form. So what we will do, taking log on both sides, so here L is equal to limit as x tends to infinity, 1 upon x raised to 1 by x. So taking log on both sides, क्या फायदा होगा log लेने का? log अगर आप लोग लेते हो तो यहाँ पे either the form will be converted into 0 into infinity form, and we know that how to evaluate the 0 into infinity form, right? We will adjust the term f of x or g of x and then again convert it into either 0 upon 0 form or infinity upon infinity form. So log L is equal to log of this, so you will get limit as x tends to infinity, so log of 1 by x raised to 1 by x. So this will becomes log L is equal to limit as x tends to infinity, 1 by x into log of 1 by x. Right? Now put limit as x tends to infinity. So 1 upon infinity is 0 and log of 1 upon infinity. So you will get here log of 1 upon infinity is 0. So here 0. Log of 1 upon infinity. So log 0 is infinity. So 0 into infinity form. It is converted into 0 upon infinity form. So what we will do? We will convert it into, see here, log L is equal to limit as x tends to infinity. So I am adjusting this 1 upon x in the denominator so that it will be converted into either 0 upon 0 or infinity upon infinity form. right? So here log of 1 by x upon 1 upon x, you can write here 1 upon x as it is here 1 by x. So log x, log of 1 upon x upon x. So limit as x tends to infinity, you will get here log of 1 upon x. Now put limit as x tends to infinity. Log infinity is 1, log 0 is infinity. So here infinity upon infinity form. Clear? So here infinity upon infinity form. So you can convert this into put limit as x tends to log of 1 upon x. So log, there is 1 upon infinity. So again it is infinity upon infinity form, but log of 1 upon x we can write here limit as x tends to 0. So log 1 minus log x upon x. Log 1 is 0. So this will becomes minus log x upon x. So limit as x tends to infinity minus log x upon x. Again infinity upon infinity form. Right? Now take the derivatives. So you will get here again by using L'Hospital rule, you will get 1 by x right here as x tends to infinity minus log x upon x, infinity upon infinity form. So limit using L'Hospital rule, you will get limit as x tends to infinity minus 1 upon x upon x. X derivative of x is 1. So this will becomes limit as x tends to infinity. Limit as x tends to infinity. Here is minus 1 upon x. So limit as x tends to infinity, you will get 0. Okay. So log L is equal to 0. So L is equal to e raised to 0 equal to 1. So limiting value of this determinate form is 1. Okay. Now next is see the example. Evaluate limit as x tends to 0, 1 upon x bracket raised to 2 sin x. Evaluate limit as x tends to 0, 1 upon x bracket raised to 2 sin x. So you will get here 1 upon x bracket raised to 2 sin x. Put limit as x tends to 0. So 2 sin 0, sin 0, 0. So you will get 0. So is it nothing but infinity raised to 0 form? Right? Is it nothing but infinity raised to 0 form? Because 1 upon infinity is no, no. And 1 upon 0 is infinity. Now, so what will take? L is equal to limit as x tends to 0, 1 upon x raised to 2 sin x. So taking log on both sides, log L is equal to limit as x tends to 0, 1 by x bracket raised to 2 sin x log of. So this will becomes log L is equal to log L is equal to 2 sin x into log of 1 by x. Limit as x tends to 0, 2 sin x into log of 1 by x. Okay. Now put x tends to 0, sin 0, 0, log of 1 by 0. So log infinity, here you will get 0. Right? Log of infinity, two into sin log x. So here 0 into infinity form. Log infinity is infinity. So here 0 into infinity form. Right? So log L is equal to, now using L'Hospital rule. Using L'Hospital rule. Using L'Hospital rule, we'll get here log L is equal to, now limit as x tends to 0. So we will adjust this to sin x. So log of 1 by x upon 1 upon sin x. Log of 1 by x upon 1 upon, so this 2 is outside, 1 upon sin x. If you observe, it is converted into infinity upon infinity form. Okay, so it is infinity upon infinity form. So ultimately here is 2 limit as x tends to 0. Log 1 by x, it means log 1 minus log x. Log 1 is 0 minus log x upon 1 upon sin x, it means cosec x. It is infinity upon infinity again. Now, so using again L'Hospital rule, you will get here log L is equal to 2 into here minus 1 by x upon my cosec square x, it means minus cosec x into cot x. Right? So this minus minus becomes plus. So 2 upon cosec x. So log L is equal to 2 into, so this minus minus becomes plus. Now 1 by x into 2 into limit as x tends to 0. There is to limit as x tends to 0. Get 1 upon x into 1 upon cosec x, it means 1 upon sin x. Cot x, it means cos x upon sin x. Right? If you observe this sin x, cos x upon this sin x. So you will get x into cos x, sin square x upon x into cos x. Right? So 2 into limit as x tends to 0, sin square x upon x into cos x. Right? So sin x upon x is equal to, here you will get sin square x. So we will adjust x, so multiplying and divide by x square. So you will get limit as x tends to 0, sin square x upon x square into x upon cos x. Right? The limit as x tends to 0, this will becomes 1. And limit as x tends to 0, this is 0. So you will get L is equal to 0. But this is log L is equal to 0. Right? This log L is equal to 0. So L is equal to e raised to 0. But e raised to 0 is 1. So value of the given indeterminate form is e raised to 0 is equal to 1. Now evaluate, now limit as x tends to 1, 1 minus x square bracket raised to 1 upon log of 1 minus x. So limit as x tends to 1. So put x tends to 1, so this will becomes 1 minus 1. So 1 minus 1 is 0, 1 upon log of 1 minus x. So this will becomes 0 into 1 upon 0, it means infinity. So 0 raised to infinity form. Right? 1 minus x square into log of 1 upon log of 1 minus x. So here is in 0 raised to 1 upon infinity. Log 0 is infinity, 1 upon infinity is 0. So here is 0 raised to 0 form. Right? So at 0 raised to 0 form, so convert it in taking log on both sides. So L is equal to limit as x tends to 1 minus x square into 1 upon log of 1 minus x, right? So this is your 1 minus limit as x tends to 1 minus x square into log of 1 minus x. So you will get log L. L is equal to log of limit as x tends to 1. That is limit as x tends to 1 log of 1 minus x square into 1 upon log of 1 minus x, right? So log of 1 minus x square upon log of 1 minus x. So you will get here limit as x tends to 1. So 1 minus 1 0, log 0 infinity, log 0 infinity. So this is infinity upon infinity form, right? As we get infinity upon infinity form using L'Hospital rule, log L is equal to limit as x tends to 1. Here using L'Hospital rule, we have limit as x tends to 1 log of 1 minus x square. So log of 1 minus x square upon, so here we'll get 1 upon 1 minus x square into derivative of 1 minus x square is minus 2x upon here log 1 upon 1 minus x into minus 1. If this minus and minus becomes plus, so we will get log L is equal to here value of log L is equal to limit as x tends to 1, that limit as x tends to 1. So you will get 1 upon 1 minus x square into minus 2x minus 1 into 1 minus x, right? This will nothing but put limit as x tends to 1, 1 minus 1 0. Ultimately this value become 1 minus x square. We can write here a limit as x tends to 1, so plus 2x into 1 minus x upon 1 minus x square. We can write 1 plus x square, 1 plus x into 1 minus x. So 1 minus x, 1 minus x cancel out. So limit as x tends to 1, 2x upon 1 plus x, right? So put limit as x tends to 1, 2 upon 2 is equal to 1. So L is equal to log L is equal to 1. So here L is equal to e raised to 1 equal to e. Hope you are getting it. And log on both sides. Now simple है, आप लोग कर सकते हो यहाँ पे cos of limit as n tend to infinity, x tends to infinity, cos of x raised to cos theta by x, theta by n bracket raised to n square. So cos theta by n bracket raised to n square. Now taking again x tends to 0. Here n tends to infinity, not x. Here n tends to infinity. So n tends to infinity, cos theta upon infinity, cos 0. Cos 0 is 1. Right? Now this is different example. 1 raised to infinity form. अब तक यहाँ पे 1 raised to infinity form आया नहीं था. 0 raised to 0, infinity raised to 0 form था, infinity raised to infinity था. But 1 raised to infinity here. So taking log on both sides. So L is equal to limit as n tends to infinity, cos theta by n bracket raised to n square. So taking log on both sides, right? So taking log on both sides, we will get log L is equal to limit as n tends to infinity, log of cos of theta by n bracket raised to n square, right? So log L is equal to limit as n tends to infinity, n square into log of cos theta by n, right? Now put limit as n tends to infinity. So this is infinity raised into 0 form, right? Here is infinity into 0 form. We know that infinity upon 0 form में तो convert करना है हमें. So L is equal to limit as n tends to infinity, log of cos of theta by log of cos of theta by n upon 1 upon n square. Now it is converted into 0 upon 0 form, right? 1 upon infinity is 0. So here is 0 upon 0 form. So let x is equal to here 1 by n. So as n tends to infinity, x tends to 0, right? So therefore log L is equal to limit as x tends to 0 log of cos theta x into theta 1 by n is x. So upon 1 upon n square, it means this will become x square. Now put limit as x tends to 0. So again it is 0 upon 0 form. Here is 0 upon 0 form. So log L is equal to limit as x tends to 0. So again using infinity again L'Hospital rule. So 1 upon cos x theta into minus sin x theta into theta, right, upon 2x. So theta by 2 is constant. So log L right here log L is equal to here theta by 2 is constant, theta by 2 into bracket you will get limit as x tends to 0. Now here minus sin x theta upon cos x theta. So is it nothing but tan x theta? Minus sign you can take outside. So tan x theta upon x. So if you observe here tan x theta upon x, so limit of this is nothing but tan x upon x, limit as x tends to 0 is 1, right? So here minus theta by 2 into limit as x tends to 0 into tan x theta. So this is 1. So you will get minus theta by 2, right? So minus theta by 2 into 1. So log L is equal to minus theta by 2. So L is equal to e raised to minus theta by 2. So one more theta is there, no? इंटू थीटा भी था ना यहाँ पे माइनस थीटा बाय 2. तो ये तो आउटसाइड हो गया, राइट, एज इट इज. तो x इज L इज इक्वल टू लॉग L इज इक्वल टू हो गया ये माइनस थीटा बाय 2. तो e रेज टू माइनस थीटा बाय 2, राइट. और थीटा इज नथिंग बट व्हाट, थीटा क्या था हमारा, e रेज टू थीटा बाय 2. दैट इज अवर फाइनल आंसर माइनस. I hope you are getting it. How to evaluate the indeterminate form 0 upon 0, infinity upon infinity, infinity minus infinity, and then 0 into infinity, 1 raised to infinity, 0 raised to 0, and infinity raised to 0 form. Okay, so all the forms are covered here, and evaluate this the same way you can evaluate this integral, these forms also. Okay. So I hope you are getting it clearly how to evaluate the indeterminate forms. If you are liking my videos, please do like, share and subscribe. Thank you so much.